Hey everyone, it's Mrs. Brimlow. Today we're going to start prepping for RICAS by reviewing how to solve equations and angle relationships. Make sure you have your packet out and you're copying down the examples as I'm going through them. So we have a nice example over here of solving for x, a variable in this equation. We will do a few examples together, but what I'd like to point out and remind you of before we start solving is the different type of solutions we could encounter. So we could have one solution, we could have no solution, or we can have infinitely many solutions. With one solution, when the equation is simplified, you're going to notice that the variable terms have different coefficients. So right away, you should know it's going to have one solution. You won't be able to tell what the solution is, just that it's going to have one solution. For equations that have no solution, when simplified, you're going to notice that they have the same exact variable term. However, they will have different constants on each side. If you solve them all the way through, you'll find that it'll be one number does not truly equal another number, like this example here. For infinitely many solutions, when simplified, you'll be able to see that they are exactly the same on both sides. And if you finish solving it all the way through, you'll find that one number is exactly equal to the other. So we're going to solve a few examples together, see what it looks like, go through the steps, and then we'll talk about angle relationships. So when we're solving equations that have variables on both sides, you can start anywhere with this. I always like to get rid of the smallest variable term first, so that would be negative 2x. Now, because negative 2x and 5x are not on the same side, I can't just combine them together. I have to use inverse operations to solve this. So I'm going to start by adding 2x to both sides, leaving me with 17 equals 7x plus 3. Now I'm down to a two-step, so I'm going to subtract 3 from both sides. So I get 14 equals 7x, divide by 7, and x equals 2. So when you're solving equations, you should be using inverse operations, showing all your steps out as best you can with the spacing provided. So for this next problem, before I actually start solving and moving things around, I'm going to simplify it first. So that means on this side, I'm going to use the distributive property, and on this side, I'm going to combine my like terms. So when I multiply 1/2 by the terms inside the parentheses, I'm going to get 2x minus 3. And on the other side, I'm going to get 2x plus 7. So if you stop for a second and take a look here, you're going to see we have the same variable term on each side, but we have different constants, which means it's going to have no solution. I'm going to keep solving so we can check that that's the case. So I'm going to subtract 2x from both sides, leaving me with negative 3 equals to 7, which is not true. So we would say this has no solution. Now, this final equation does not have variables on both sides, but it is a review on working with fractions that may not be as simple as working with 1/2, 1/3, and so forth. So we start with the distributive property. So I'm going to multiply 2/5 by everything inside of the parentheses. 2/5 times x is just 2/5 x. When I go to do 2/5 times 10, you can solve it two different ways. Fractions are division problems. So if you take the number and divide it by the denominator, which is 5, so 10 divided by 5 is 2, then you multiply it by the numerator, which is 4. If that was confusing or your brain doesn't understand that, then what you can do is 2/5 off to the side times 10, and we write all whole numbers as fractions over 1. So we multiply across, which gives us 20 over 5. I can simplify that to be 4. Either way works. And then I'm just going to finish solving the equation. So from here, I'm going to subtract 4 from both sides. So 2/5 x equals 5. And then when we divide here, since it's 2/5 times x, we would divide by 2/5 on both sides. When dividing fractions, you use keep, change, flip. So really this is going to be 5 over 1 times 5 over 2, which is 25 halves. And you can leave it like that. You could change it if you wanted to, though, to 12.5. So once again, this is a review of solving equations. So next, that's going to lead us into talking about angle relationships. So this year we talked about parallel lines when cut by a transversal, the different types of angle pairs that they form. They give us one example of each of these types of angle pairs within the diagram, and I'm just going to run through them quickly. I do want to point out before I start, though, that all these angle pairs are either equal or congruent to each other, or they add up to equal 180, making them supplementary. So corresponding angles are red. I like to think of cut and paste. So they're both in the same place, either above or below a parallel line, and they're on the same side of the transversal. Now, this is just one example. All of these different types of angle pairs have multiple examples in a diagram. So this is just one example. You could also go the two below on this side, two above on this side, or two below, and they are congruent. Next, we have alternate exterior. Alternate means opposite sides of the transversal. Exterior means outside the parallel lines. So we can see in orange this example. We could also have it on the other side as well, and those angles are congruent. Next, we have vertical angles. Vertical angles are across from each other in this diagram, and they are in yellow. We could also have an example like this, like this, like this. Same side interior. So same side is the same side of the transversal, and interior is inside the parallel lines. This example is in green. We have another example over here, and they are supplementary. They add up to equal 180 degrees. Next, we have alternate interior. Alternate means opposite side. Interior is inside of parallel lines. So this we have in blue. We could also have another pair right here as well. And then we have same side exterior. So same side of the transversal, outside the parallel lines. So that's in purple. It could also be on this side as well, and they add up to equal 180. And I'm not sure if I said this before, but parallel lines, they're two lines that will never cross, and the transversal is this line that cuts through them, forming these different angle pairs. We mostly focus this year on two parallel lines, but you could have 3, 4, any number of parallel lines you wanted to work with. So you just have to be careful when you're looking at them to determine what the angle pair is, depending on which parallel lines you're looking at. So the first question we're going to answer is list all angles that are congruent to angle 8. So before we do this, I want to go back into the diagram and label the angles, so then we can answer both of these questions. So I'm going to call this angle 1, 2, 3, 4, 5, 6, 7, and 8. So the angle we're looking at is number 8, and we're looking for all the angles that are congruent or equal to this. So one angle that is congruent is number 5, and that is because they are vertical. So angle 5. Another angle that is congruent to 8 is angle 4, and that is because these are corresponding. It's also because these two are alternate interior, and these two we determined were congruent. The final angle that is congruent to angle 8 is angle 1. It is alternate exterior to 8. It is vertical to 4. It corresponds with 5. So there's several different relationships you can use once you get started seeing how they're all connected. So if the measure of angle 1 is 105, find the rest of the angle measures. You only need one angle to find every other angle measure here, because all the angle pairs are either congruent or add up to 180 degrees. So angle 1 equals 105 degrees. So up here, I'm just going to label this is equal to 105 degrees. So based on this, we should be able to find the rest. So first, I'm just going to write them all out. Now we know from the previous problem we have several angles that are congruent to angle 1, so let's go through those first. So starting with angle 1 up here, I know that angle 4 is congruent because they are vertical. So if 1 is 105 degrees, that means 4 is 105 degrees. Another angle that is 105 degrees is angle 5. That's because it corresponds with 1, and it's also alternate interior to 4. So angle 5 is 105, and our last angle would be 8, which is 105 degrees. It's vertical to 5, alternate exterior to 1, and corresponding to 4. So several different examples there. 2, 3, 6, and 7. Once we find one of those, we'll find the rest. So going back to what I said before and taking a look at these definitions, all of these angle pairs are either congruent, which is what we saw in these first 4 angles, or they are supplementary, meaning they add up to equal 180 degrees. So going back to angle 1, which was given to us, 105 degrees, angle 1 and angle 7 are an example of same side exterior. Same side exterior add up to equal 180 degrees. So if I take 180 and subtract 105, that leaves me with 75. So that means angle 7 is 75 degrees. So from here, from 7, that also means 6 is 75 degrees because they are vertical. That also means 3 is 75 degrees because it is alternate interior to 6. And that means 2 is 75 degrees because that is vertical to 3. So now you are going to complete the RICAS review problems on a separate sheet of paper.